My name is Kenneth Olsvik. I will take you through this presentation. Xsens, we deliver clamp-on meters. And basically what it looks like is what you see here. You have two parts that is coming together like this on the outside of the pipe with the transducers. And you have a cover covering it for weather protection, etc. So what does this have to do with digital fields? Well, in a way, you always need to have inputs of data to digital your field. And having a clamp-on capability means that you basically can install these meters anywhere. As you see from this picture here, you install the meters on different pipe sizes, and also you can install them after a band, very close to a band. If you look very carefully here, you will see that some of these is almost just after 90 degrees bands. And we could do that because we could compensate for uneven flow distribution and still get accurate readings. But also for brownfield management, where you maybe have depleting production or increasing water cut, the meters can then be installed where you maybe have lost your production data because the production is so low that it's out of the operation range of an existing meter. Then you could clamp on this meter and you will have your readings back because we could go down to extremely low flow rates. We have like a turnover ratio of 400:1 on these meters, so we could handle that. And also on flow insurance, of course, these meters can be used. So we tried to make a little overview of what we see as pains in the metering. And basically, we believe that we could handle those. If you look at what I mentioned, that we could install these closer than 10 diameter upstream or 5 diameter downstream of band, we can do that. And that is really favorable, especially if you're an offshore platform or a place where you have restricted areas. Clamp-on can be, of course, be installed anywhere, so you don't need to stop any production or cutting any pipes. The cost of the meter, including installation cost, is typically 50% lower than a conventional meter. And as I said, there is absolutely no possibility for any leakage because it's clamped to the outside. And there is no contact with the erosive or corrosive fluids, so the maintenance is extremely low. And you could basically install this in a couple of hours, and it's very easy and lightweighted, so it can be stored by one person. So typically installation here will be that you install these on maybe after a separator where you have a gas rate outlet, oil rate outlet, and water outlet. And then you could put the meters on all of them because you could measure all of that. We are using time of flight, ultrasonic time of flight, to measure flow rate, and we could also measure with the speed of sound fraction, meaning that we could also measure water cut with these meters. So if you look at for typically a separator on the oil lag, today you basically need to have a flow meter and you need to have a water cut meter, and combine that, so you need to have 2 meters. As you see from the picture on the bottom, this is a meter we installed on the FPSO. And here you see that the meter is doing exactly the same in 1 meter. So you basically get 2 meters for one. Measure up to 0 to 100% water cut. And in addition to that, the flow rate. So how is this possible? I mean, there's been clamp-on meters in the market maybe for 20 years. But one of the maybe downside of it have been that it have never been very accurate. And that we have really done something about. So we have come up with a completely new way of doing this, which we have patented. But if you look at the bottom of this slide, you will see a conventional clamp-on meter. And however you install those clamps and the detectors, you could only measure one velocity through the center of the pipe. And that means that if you have an uneven distribution, or if you want to measure what is close to the pipe wall where the flow is much lower than in the middle, you can't do that. You just can measure the center. And by such, you can have up to 10% uncertainty. That is the reason why you have had this high uncertainties. If you look in the middle one, that's a typical inline multipath ultrasonic meter normally used for physical applications. Here you see they have drilled holes in the pipe walls. And by that, you could measure the flow velocity profile fully, also measuring in the center, but also close to the pipe wall. And that's exactly what we have done, but with a clamp-on meter. We have introduced something we call helical-shaped transducers, and with combining those with axial transducers as used in conventional clamp-on meter, we can measure the full velocity profile. So this is completely new and unique. And it means that on accuracy, we could compete with the existing inline meters. Cost, we are lower, and reliability, definitely much better than anything that's out there, because there will never be a leakage. There isn't any flanges, there isn't any penetration to the media. It's just clamped to the outside. Well, that was a little bit about the theory. Then it's the proof of the pudding is, okay, show us some proof. And here you see results from one of the first meters we put out back in March last year. This was with Aker BP in the North Sea, where we put in a meter, as you see on the picture there, on the FPSO, and we tested it up against the inlet separator where they had physical reference measurement. And we saw that we got accuracy within plus minus 1% for the flow rate and plus minus 1% for the water cut, which is quite extreme for a clampometer. We can also measure gas. This is test results we did with Equinor back in 2019, where we qualified a meter for being used for gas. And you see all the test results here, basically within plus minus 2%. And in fact, we also depleted the meter into water to see if we could use it for subsea, and we could that. After this, in fact, Equinor bought a lot of these meters, which now is going to be installed on a gas compressor unit for testing, and it's going to be installed in shallow water for testing together with Equinor. We have also done a couple of meters for water injection flow, as you can see here on the slide with Aker BP, measuring the injection of water, liquid flow rate and water cut. And also onshore, of course, we could install these meters of the separators. And we also just developed the meter for measuring mud flow. So we could measure mud being pumped in and mud coming out of the well. But there is heaps of applications for this technology, because basically we can measure anything that is in a flowing pipe. So whether this is in the oil and gas industry and all these items mentioned here, we could do it, but we could also use it in process industry and water industry, etc. This is just showing the project that we have had gone ongoing, and it's still not fully completed, but where we have tested it for mud, which was sponsored by a couple of oil companies and also Baker Hughes. And the reference we have so far, you see here, you give an indication that we are involved with the big players in the market. And as you can see, we got also the statement from Aker BP just recently, where they showed their gratitude for the meters, and the meters is working very nicely. So that was a short presentation from me. Here you see some of the awards we have received in the 2 last years. And why we are doing this is that we really want to get in contact with you. We want to have an opportunity to try this out with you, going for a trial or whatever. And please contact myself if you have any questions, and if you don't want to raise it now, or you have any application you want to look into. So with that, thank you very much.